I'll begin by stating that I did not come to endorse or criticize specific policies. My objective is to provide information that can be used to inform policy decisions. Thus, the approach that I'll take when discussing this topic is to limit my remarks to the science of climate change. As Doug O'Malley mentioned a little while ago, Working Group 1 of the Intergovernmental Panel on Climate Change, which is a collection of many of the world's top climate scientists, recently issued its latest report on the physical science of climate. This report reaffirms much of what we already know about climate change and its causes. In the report, the observed warming of the climate system is described as unequivocal, with many of the changes observed since the 1950s regarded as unprecedented over periods as long as, in some cases, thousands of years. Global average temperature has risen by 1.5 degrees Fahrenheit since the late 19th century. In each of the last 3 decades, temperatures at the Earth's surface have been warmer than the previous one and warmer than any decade since modern thermometer records began in 1850. During the past 20 years, the great ice sheets that cover most of Greenland and Antarctica have been shrinking, as have almost all the mountain glaciers throughout the world. Since the middle of the 19th century, global sea level has been rising at an average of 7 inches per century, and the rate of rise has been roughly double that during the past 20 years. Heat-trapping gases in the atmosphere, most notably carbon dioxide, have reached levels that are unprecedented in at least the last 800,000 years. The basic physics of how these heat-trapping gases affect climate has been understood for over a century. The latest IPCC report concludes that it is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century, and that phrase, extremely likely, indicates a likelihood of 95 to 100%. The changes in climate that the world has experienced are expected to continue and intensify. Future climate will feature more frequent and longer heat waves and fewer cold temperature extremes. Heavy rain events over middle latitude continents such as North America are expected to become more intense and more frequent as the climate warms. The rate of global sea level rise is expected to increase during the 21st century. What about climate change in New Jersey? Looking back at records, New Jersey's average temperature has risen at a rate of just over 2 degrees Fahrenheit per century, or somewhat faster than the global average. 9 of the 10 warmest calendar years on record have occurred since 1990, and the 5 warmest years have occurred since 1998. Summers have been unusually warm, with 6 of the 10 warmest summers taking place since 2005. Unusually warm months have been far more prevalent than unusually cold months, outnumbering them by 25 to 2 since 2000. The trend toward higher temperatures is expected to continue in the decades to come as the concentrations of heat-trapping gases continue to increase. Annual precipitation has undergone an upward trend of just over 4 inches per century since statewide records began in 1895. Increases in the amount of precipitation falling in heavy precipitation events have been noted throughout the northeastern United States, including New Jersey. By one measure, the frequency of these events has doubled over the past 2 decades. There's good reason to expect this trend will continue, as heavy precipitation events are anticipated to become more intense and more frequent as temperatures increase, with implications for the frequency of inland flooding along New Jersey's rivers and streams. Sea level rise along the New Jersey coast has been more rapid than the global average because the land is subsiding at the same time that water levels are rising. At Atlantic City, where records extend back to 1912, sea level has risen by an average of 1.5 inches per decade. As the ocean continues to warm and glaciers and ice sheets continue to melt, sea level rise is expected to accelerate. A recent study by some of my colleagues at Rutgers has estimated that sea levels on the New Jersey coast could rise by 7 to 16 inches by the year 2030, 13 to 27 inches by 2050, and 29 to 69 inches by 2100, all those levels relative to what they were in the year 2000. The evidence for changes in storm activity, including tropical storms and hurricanes, is mixed and remains an area of active research. Recent studies suggest that the global frequency of tropical cyclones, that is, hurricanes and tropical storms, will either decrease or change little in response to global warming. But their average intensity is likely to increase in terms of both maximum wind speed and rainfall, and the frequency of the most intense storms is expected to increase. Of course, what we would really like to know is how the risks to New Jersey from hurricanes and other storms will change in the future. Unfortunately, we do not have great confidence in regional projections of future storm activity, but there is high confidence that the impacts of future storms in the form of coastal flooding are likely to become more frequent and more severe due to rising sea levels. This is because sea level rise will raise the baseline for coastal flooding events. Many of our traditional strategies for planning for future weather and climate events assume that they will look a lot like the events that we have experienced in the past. Climate change invalidates this assumption, creating a need to prepare for and adapt to conditions that will likely be quite different from what we have seen in the past. Because the primary driver of future climate change is the emission of carbon dioxide into the atmosphere, there is the potential to mitigate the impacts of future climate change through reduction in carbon emissions. Whether to do so, and to what extent, is a policy decision that must be made by society and those who serve as its leaders. But regardless of what policy direction we ultimately follow, we are already experiencing changes in climate, and there is no realistic scenario in which all future changes can be avoided. Thus, it will be necessary to adapt to the changes in climate that are already wired in, even if mitigation policies are implemented to reduce carbon emissions. What combination of mitigation and adaptation to pursue is a matter of policy on which I will take no position, except to note that it is not an either-or proposition. Finally, what I think is paramount is that decisions should be informed by the best available science. I hope that I have helped somewhat in that regard by summarizing our current understanding of the science of climate change. And I thank you again, Mr. Chairman, and the other members of the committee for having the opportunity to talk with you today.